Unit 4.1, Practice Worksheet 1. Determine whether the given ordered pair is a solution of the system. So what we'll do is we'll take the ordered pair xy and plug it into each of the equation. First, x equals 2y plus 8. That means it is 2 equals 2 times negative 3 plus 8, which means 2 equals negative 6 plus 8, and that is true. Plugging it now into 2x plus y equals 1. That's 2 times 2 plus negative 3 equals 1. That's 4 plus negative 3 equals 1. That's true. So this is a solution. I'll just put solution here. Okay, coming over here to number 2, we have A and B this time. Your ordered pairs are always alphabetical, so that means 20 equals 1/4 times 40 plus 10, which means 20 equals 10 plus 10. That is true, so it is a solution for this equation. Plugging it into the other equation, we have B minus A equals negative 20, so that is 40 minus 20 equals negative 20. So that's 20 equals negative 20. That is not true. So this is not a solution. Moving on to number 3. Solve these systems graphically. So we're going to graph each of these and see where they intersect. So the slope for the first equation is negative 2 and the y-intercept is 5. So 1, 2, 3, 4, 5. We'll graph that. And a slope of 2 means rise 2, run 1, which will put us right there. Okay, and the second one, before we got to get y by itself, so we'll divide everything by 2, and we end up with y equals 5 halves x plus 5. Has a y-intercept of 5, 1, 2, 3, 4, 5. So you can see they're going to intersect right there at the y-intercept. Now 5, 2 would mean up 5 and 2 to the right. When that goes off, you can make them both negative, which will then down 5 and to the left 2 gives us two lines that are very close, but they intersect at 0, 5. Okay, so taking this line, I think what I'll do is I'll solve for the x-intercept and the y-intercept. So I'll go 2x minus 4 times 0 equals negative 4. And I will get 2x equals negative 4, which means x equals negative 2, and I divide both sides by 2. So I'll get negative 2, 0 for the x-intercept. And now solving for the y-intercept, I get 2 times 0 minus 4y equals negative 4. That goes away. I divide both sides by negative 4, and I get y equals 1. So I have a y-intercept of 0, 1. Okay, graphing those 2 points, negative 2, 0 and 1, 0 gives me this line right here. And now taking y equals 1/2 x minus 2 means I have a slope of 1/2 or 1 over 2 and a y-intercept of negative 2. Well, here's the y-intercept of negative 2. Rise 1, run 2. Puts me right there. Okay, now either these two lines are parallel or they're going to meet way out in space somewhere. And if I look at this line, I see rise 1, run 2, rise 1, run 2. So this has a slope of 1/2, and this has a slope of 1/2. So these two lines are parallel. Same slope means they're parallel. So we would say there is no solution. There's no point of intersection. Moving on to number 5 and 6. All right, I think I'll graph this guy by finding the x-intercepts. So 2x plus 3 times 0 equals 12. Divide both sides by 2, and I get x equals 6. So I have an x-intercept of 6, 0. I'll plug that in a second time, and 2 times 0 plus 3y equals 12. That cancels. Divide both sides by 3, and I get y equals 4, which means I have a y-intercept of 0, 4. If I graph 2, 4, 6, 0, and 2, 4, 0, and I connect those 2 points, I get that line right there. Okay, now graphing x equals 3, that is a vertical line that runs along x equals 3 here. Remember, no y-intercept, so that line is right there. And so the point of intersection is at 3, 2, which means that is the solution to the equation. Okay, moving on to number 6. We have the first line is y equals 2 over 3x plus 2, which means a slope of rise 2, run 3, or 2/3, and a y-intercept of 2, which gives us the y-intercept of 2 right there, and then rise 2, run 1, 2, 3, rise 2, run 1, 2, 3. If we connect those 2 points, our line should look like that. And then taking the other line, let's go ahead and let's move that into, just so we're at practice, I'm going to go ahead and put this in slope-intercept form by subtracting 4x from both sides. Gives us negative 6y equals negative 4x minus 12. And then dividing everything by negative 6 to get y by itself, we get y equals negative over a negative is a positive. 2 goes into both of those. So we get 2/3 x minus 2, which means we have a slope of 2/3 and a y-intercept of negative 2. Does that slope look familiar? Same slope, different y-intercept. So these guys are going to be parallel, which means no solution. But let me finish. 2/3 slope means rise 2, run 3. And another set of parallel lines. Going on to the back of 4.1. Okay, let's take a look at what we're doing here. Number 7, you are looking for an after-school job. One job pays $9 per hour, another pays $12 per hour, but you must buy a uniform that costs $40. After how many hours of work would your net earnings from either job be the same? Write 2 equations to model the situation. Graph the equations to solve the problem. Okay, so the first job at $9 an hour, you simply is your pay, we'll say P equals 9 times the number of hours you work. Okay? And the second one is basically the same. It's your pay equals $12 times the number of hours you work, but you have to subtract the $40 you have to pay for your uniform. All right. So let's see here. I'm going to put our y-axis here at I'm going to believe this is our y-axis, but I'm going to make our x-axis, let's see, make our x-axis right here. Not sure if this is going to fit on our graph. And the reason I do that is that's where X, or we'll say hours, are 0, and this is where our pay is 0 right here. So if we go, we're going to call this, let's see, we're going to call these every 5 hours, or let's do it this way, let's do it every 3 hours. So 3 hours, 6 hours, 9 hours, okay, every 3, and we'll call this I guess we're going to stick with every 10. So this is be $10, $20. Alright, so in 3 hours you'll make $27. Well, shoot. I guess we'll go over 2 hours. 2 hours here, every 2. So 2, 4, 6, 8, 10, 12, 14 hours. So in 2 hours you would make $18, which would be about right here. And in 4 hours you would make $36, which would be right about here. And so on. So in 6 hours you're going to make 6 times 5 is 54. And so in 10 hours you're going to make $90. So 10, 20, 30, 40, 50, 60, 70, 80, $90. So your first job, $9 an hour, you'd start at 0, but in 10 hours you would make $90. Okay, now your second job, you're going to make $12 an hour, but you have to pay that $40 up front. So you're actually going to start off in the hole $40. So your starting point is here. But in 10 hours of work, you're going to be at $120. You've earned $120. So in 10 hours of work, there's 10, 20, 30, 40, 50, 60, 70, 80, 90, 110, 120. So we're starting here at negative 40. And so it looks like the break-even point is somewhere around this point right here, which would be, let's see here. Somewhere around 13 hours. So let's see what happens when our break-even. Let's try 13 hours. Let's see how close we are. 9 times 13. Your P is, what is that, $117, and equals 12 times 13 minus 40. Let's see, that is 100 and, what do we got there, 156. Look at that, 116. So pretty close. So we'd break even right around 13 hours. So if you were only going to work if you were only going to work at this job for, say, 12 hours, I would work at the $9 an hour job. But if you're planning on staying in this job for more than 13 hours, 13 and up, you'd take the $12 an hour job. Okay, moving on to number 8. If the graph of two linear equations is a system, do not intersect. If the graph of two linear equations in a system do not intersect each other, what does that tell you about the solution of the system? Explain your answer and include a diagram with your explanation. So when two lines are parallel, it means they never intersect. Parallel lines will never intersect, which means there is no solution. Remember, the solution to a system of equation is the point where they intersect. These two lines are parallel, so they will never intersect. So there can be no solution. Number 9, what is the graph? Without graphing, decide if the following system of equations has one solution, no solutions, or infinite solutions. Show the work you did to support your decision. All right, well, if these two guys are going to be no solutions, they would have the same slope, being parallel. And they don't have the same slope. So these two lines will have one solution. Infinite solution. Oh, I'm sorry, we better convert this guy before I say that. I may be wrong. So we're going to make this guy, we're going to get this guy into slope-intercept form. I might have misspoke here. I will subtract 8x from both sides. Boy, no I won't. Let me start over here. We're going to just add 16 to both sides. And that will give us 8x plus 16 equals 2y. I'll divide everything by 2, and we get 4x plus 16 equals y. To make that a little more presentable, we'll move the y over there, and we get y equals 4x plus 16. Okay, now we've got a little different situation here. This guy has a slope of 4, and this guy has a slope of 4. So these two lines are parallel, which means they will never intersect, so there is no solution. They are two different linear equations, and they are parallel, so they will never intersect. Now, if they had the same y-intercept, then they would be infinite many solutions, because the two lines would be right on top of each other. Same slope, same y-intercept, infinite solutions.